Calculate the number of moles of aluminum that will react with 1.52 moles of oxygen to form aluminum oxide. The balanced chemical equation is written below. In these types of problems, sometimes a flow chart can be useful. This will actually be just a one-step problem, though, where we're going to go from a certain number of moles of one compound to a number of moles of another compound. On the left, I'll put moles of oxygen, because that's what I was given. It's what I have. And then what I want, or what I'm asked for, is the number of moles of aluminum. So for this type of problem, the vehicle that gets us from moles of one compound to moles of the other compound is we use the balanced equation. Of the components of the reaction. So it tells us here that 4 moles of aluminum combines with 3 moles of oxygen. We could even write that in words. 4 moles of aluminum combines with 3 moles of oxygen to make 2 moles of the product, Al2O3. Now from that balanced equation we can write the conversion. It is that 3 moles of O2 combines with 4 moles of Al. So like I had done in previous problems where we had done some conversions, you put what you have on the left and what you want on the right. We have moles of O2. In fact, we have 1.52 moles of O2. But we want moles of Al. So we'll put an equals there, and we'll introduce a conversion factor that we can multiply our 1.52 moles of O2 by. In order to make the conversion, we have to have moles of O2 on bottom. This will cause the moles of O2 to cancel. And then we're going to want moles of Al on top because that's our desired units. Then we simply use the numbers given here from our balanced equation. 3 moles of O2 combined with 4 moles of Al, and we can multiply to find the answer. So I get 2.03 moles of Al. Now let's try one where the flowchart has to be a little bit bigger. Now let's try one where the flowchart is going to have several steps. This one says, calculate the mass of chlorine in grams that can be produced by electrolysis of 20 kilograms of sodium chloride in concentrated aqueous solution. The balanced equation is given, but this time we're not given a number of moles of sodium chloride. We're given kilograms. So there's an additional step to change that kilograms into moles. I'll start with the middle of the flowchart though. We're going to want to change from moles of NaCl to moles of chlorine at some point. And we'll use the balanced equation to do it. But the additional step is that we're going to have to change our kilograms of NaCl into moles of NaCl. And this is something we've done in the past. The way you change from kilograms to moles is by using the molar mass on the periodic table. And we also want to consider what we're asked for. We're asked for the mass of chlorine in grams. So we're going to want to change our moles of chlorine then into a mass. The way we'll get from moles to grams will again be the molar mass on periodic table. And that is our flow chart. Notice that we would never go from grams of one compound directly to grams of another compound. We can't do that because we have to use the balanced equation. We have to use their mole ratios at some point in the problem. So we will not do this. Okay, I'll put what I have on the left. That is 20 kilograms of NaCl. Now way over here on the right, what I want is grams of Cl2. And there could be multiple conversion factors to make this problem complete. So one of the first things I'm going to do is I'm going to change the kilograms into grams, because our molar mass on the periodic table is going to be grams per mole. So let's just go ahead and change that right away. There's 1,000 grams in every kilogram. That'll take care of this part. So we have our mass in grams now. I'm going to go to the periodic table and look up the molar mass of sodium and chlorine. Okay, sodium's molar mass is 22.99. And chlorine's molar mass is 35.4. Since a sodium chloride compound would include both a sodium and a chlorine, we want to figure that that compound's molar mass would be the sum of those individual molar masses. So we want to add them together. I get 59.42 grams per mole. So we want to now use that molar mass to get us from the first step to the next step. Notice that we're going to have grams on top, so we need grams on bottom so that they cancel, and we'll want moles on top. Now the 59.42 goes with the grams, so that actually needs to go down here, and that goes with 1 mole of NaCl. At this point, we'll know how much sodium chloride we have in moles, which is great, which means that we're at this step now. We now want to go from moles of NaCl to moles of Cl2. And for that, we'll just use the ratios that we see in the balanced equation. So there's just assumed to be a 1 next to the Cl2. So 2 moles of NaCl will yield 1 mole of Cl2, according to this balanced equation. So we want to write that now as a factor. And we could be specific here and say that this is moles of NaCl on bottom, and we want to put moles of Cl2 on top. And we just put the numbers that we see in the balanced equation with them. So we get 2 moles of NaCl goes with 1 mole of Cl2. Now we have our number of moles of Cl2, so we're at the last step at this point. We just have to introduce one more conversion. We'll convert moles of Cl2 to grams of Cl2. Now we had said before that chlorine had a molar mass of 35.43 grams per mole. But this chlorine gas molecule, of course, is a chlorine bonded to another chlorine. So its molar mass will be 2 times the molar mass of just a chlorine alone. So Cl2 has a molar mass of 70.86 grams per mole. All right, now since we want grams on top at the end here, we'll put grams on top in our conversion factor. And we'll put moles on bottom. And we'll put our 70.86 with the grams and just a 1 with the moles. Now we just want to multiply and divide as necessary to get the final answer. On calculator, you could write this as 20 times 1,000 times 1 times 1 times 70.86. So you just multiply straight across with the numerators. And then a quick shortcut here is to just divide by anybody who's down below in the denominator position. You can type it in just like that on like a TI 30 X2S or TI 84 calculator. I get 11,900 grams of Cl2, which is quite a lot, but it also said we started with 20 kilograms of sodium chloride, which is quite a bit. So this would be about 12 kilograms of chlorine gas.